All right, next we're going to take a look at the sum and difference identities. So these allow us to evaluate for angles that aren't necessarily, don't fit into our special right triangles, I should say. So if we need to find cosine of, let's say, 75 degrees, we can use these formulas to split up the 75 as like 30 degrees plus 45 degrees, two angles that do work for our special right triangles. And so these formulas allow us to do that. If we have the sine of alpha plus beta, then it's the sine of alpha cosine of beta plus the cosine of alpha sine of beta. Or if it's minus, then it's just a minus sign in between. If we have the cosine of alpha plus beta, then it's equal to the cosine of alpha times the cosine of beta minus, so it's the opposite sign of what you had here, sine of alpha sine of beta. If it would have been the cosine of alpha minus beta, then it's the cosine of alpha cosine of beta plus the sine of alpha sine of beta. So the cosine is the opposite sign of what we start with. If we have the tangent of alpha plus or minus beta, then it's going to equal the tangent of alpha plus or minus the tangent of beta. So the top one is the same sign as the original. And the denominator, it's 1 minus or plus, so the opposite sign of what you had before, the tangent of alpha, tangent of beta. So there's a few different cases here. Case number 1, we are evaluating non-special angles. The first step is to find special angle values that add or subtract. So hint, look at the unit circle, and then substitute into the formula, evaluate, and simplify. So with the cosine of 75 degrees, again, right away I saw that that would be 30 degrees plus 40 degrees. 45 degrees. Because 30 plus 45 is 75 degrees. And we know both of those are angles in our special right triangles. So, if I draw my special right triangles for quick reference, pi 6, and then our isosceles right triangle, remember that's pi 4ths for both of those angles. 45 degrees. Okay, so if we want to do this, we use our cosine formula here, which says we're going to do the cosine of 30 degrees times the cosine of 45 degrees. Then we do the opposite sign of what we had. So because it was a plus sign, now I do a minus sign. Sine of 30 degrees times the sine of 45 degrees. All right, so cosine of 30 degrees. Well, 30 degrees is pi 6. So here's my 30 degrees. Cosine is adjacent over hypotenuse, so it's the square root of 3 over 2. These are first quadrant angles, so I don't have to worry about any of them being negative. And then cosine of 45 degrees, cosine of pi 4ths is always 1 over the square root of 2, or rationalized, it's the square root of 2 over 2. The sine of 30 degrees is opposite over hypotenuse, so it's 1/2. And then the sine of 45 degrees is 1 over the square root of 2, which again rationalized is the square root of 2 over 2. So we get the square root of 6 over 4 minus the square root of 2 over 4. So because they have a common denominator, we can go ahead and write that as a single fraction. And so we get the square root of 6 minus the square root of 2 all over 4. So there was my first step, breaking it down. Here's my second step, plugging into the formula. Here's my third step where I'm evaluating, and then I'm simplifying. All right, so sine of 7 pi over 12. Well, to get 7, we could add 3 and 4, so let's think about this. If we had 3 pi over 12, plus 4 pi over 12, that would give us 7, and what would these reduce to? Well, 3 pi over 12, they'd both divide by 3, so it'd come down to pi 4ths. 4 pi over 12, they both divide by 4, which brings us down to pi 3rds, which we can do. Those are both angles found in our special right triangles. So we'll do the sine of pi fourths plus pi thirds. Or if we prefer, we could say that in terms of degrees. So remember, pi fourths is 45 degrees. Pi thirds is the 60 degrees, because this is equal to the sine of 105 degrees. Remember, if you take 7 pi over 12 and multiply by 180 over pi, we convert to degrees. So the pi's divide out. 12 will go into 180 15 times. So 7 times 15. So 7 times 5 is 35, carry the 3, 7 times 1 is 7, plus 3 is 10. So that's how we get the 105 degrees. If it's easier for you to break it down in degrees. So 105 is equal to 45 degrees plus 60 degrees. All right, so now let's plug it into our formula. So we've got the sine of 45 degrees times the cosine of 60 degrees plus, because sine matches the original, we've got cosine of 45 degrees times the sine of 60 degrees. And now we evaluate. So we know the sine of 45 degrees is square root of 2 over 2. Cosine of 60 degrees, well, that is the pi thirds. And so if we want cosine, it's adjacent over hypotenuse, so it's 1/2. Again, cosine of 45 is square root of 2 over 2. And then sine of 60 degrees. So again, 60 degrees is pi thirds. Sine is opposite over a hypotenuse, so square root of 3 over 2. And so if we simplify here, we get square root of 2 over 4 plus the square root of 6 over 4. And again, because we have that common denominator, we can just go ahead and put it together as a single fraction. And so that would be our answer. All right, so the next one, we've got 255 degrees. Well, I notice 55, and so it instantly makes me think about like 45 degrees. And there's, multiple ways you could do these, but I'm thinking, what if we do 210 degrees plus 45 degrees? And then we just have to think about 210 degrees. What would the reference angle be there? So 210 degrees, we're down here in quadrant 3. It would be from here all the way to there. And the question is, how far away from 180 are we? 30 degrees. So this is our reference angle for 210 degrees. Theta prime will be 30 degrees. So we will do the sine of 210 degrees times the cosine of 45 degrees plus the sine of 45 degrees times the cosine of 210 degrees. And so now if we evaluate, so again, 210 degrees, the reference there is 30 degrees. So if we want the sine of 30 degrees, here's 30 degrees, so it's 1 over 2. But down there in quadrant 3, it's going to be negative. So it's negative 1/2. We know the cosine of 45 is square root of 2 over 2. Plus the sine of 45 degrees is also square root of 2 over 2. And then the cosine of 30, so again, 30 is here. Cosine's adjacent over hypotenuse, so it's square root of 3 over 2. And again, down there in quadrant 3, it would be negative. And so when we simplify, we get negative square root of 2 over 4. And then minus square root of 6 over 4. So we can go ahead and put that together. And see that we get negative square root of 2 minus the square root of 6 all over 4. All right, so if we have the tangent of negative pi 12ths, so if we convert that to degrees, so remember, if you take pi over 12 times 180 over pi, the pi's divide out, 180 divided by 12 is 15. So this is the equivalent of negative 15 degrees. So we could do tangent of 45 degrees minus 60 degrees. I'll break it down. So then our tangent formula tells us we want the tangent of alpha plus the tangent of beta. Oh wait, we have a minus. We're going to do tangent of alpha minus the tangent of beta. So tangent of 45 degrees minus tangent of 60 degrees. Remember, the first sign always matches what you have here. And then in the bottom, it's 1, the opposite sign of what you had before. Tangent of alpha, tangent of beta. So tangent of 45 degrees times the tangent of 60 degrees. And so if we simplify this, well, we know the tangent of 45 degrees is 1 because it's our isosceles. So tangent is opposite over adjacent. So 1 over 1 just equals 1. And then minus tangent of 60 degrees. Well, here's your 60 degrees, so tangent is opposite over adjacent, so it's just square root of 3. In the bottom, we've got 1 plus 1 times the square root of 3. So we have 1 minus the square root of 3 over 1 plus the square root of 3. We've got to rationalize that. We can't have a square root in the denominator, so remember to rationalize when you have a binomial. So because there's 2 terms down here, to rationalize and get rid of that square root, we multiply by what's called the conjugate. The only thing we change is that middle sign. We're going to do it in the top and the bottom to maintain value. So we're going to distribute, use a box, FOIL, however you like to multiply your binomials. So we're going to get 1 minus the square root of 3 minus the square root of 3 plus 3 in the top. In the bottom, you're going to get 1 minus the square root of 3 plus the square root of 3 minus 3. So if we simplify in the top, 1 plus 3 gives us 4, minus 2 of those square roots of 3. In the bottom, you've got 1 minus 3, which is negative 2, because remember, these are opposites and add to 0 and cancel out. If they don't, you did not multiply by the conjugate, or you got something wrong in your multiplying. They should be opposites, add to 0. This became a whole number because we squared a square root, so we just have a nice whole number down here. And then we can finish actually divide and get negative 2 plus 1, square root of 3, for our value there. All right, so that's case number 1, where we are evaluating non-special angles using these sum or difference formulas.